Okay, welcome. Here's a video for tonight. Excuse me. Alright, my sequence is D sub n. Here's the rule that's going to generate the terms, and for the first term I plug in a 1. Okay, it's 15 over, in parentheses, negative 3 to the n power. Alright, so my first term I plug in a 1, and I get 15 over negative 3 to the first power, which is this right here, negative 15 over 3. Okay, this ends up being a 15 over negative 3, so this would be a negative number, okay? I plug in a 2 and I get this. I plug in a 3 and get my third term, and a 4 and get my fourth term, okay? Alright, so here's my first 4 terms. Alright, I'll get my common ratio, okay? How do I get from here to here? I multiply by r times r times r. How do I figure out what r is? A term divided by the preceding term, okay? That would be a sub n, some term divided by a sub n minus 1, the preceding term, okay? That equals r, okay? Alright, so I've written out these terms in different manners. This is negative 15 over 3, 15 over 9, negative 15 over 27, and so on. I simplified these a bit here. Negative 5, 5/3, negative 5/9, and so on. Notice why the signs alternate, negative, plus, because as you'll see what our common ratio is, it's going to be a negative, but notice how I've got negative to an odd, even, odd power, even power. Any negative to an even power is positive. Okay, so I got interrupted. Sorry, I had to put it on pause. I kind of lost track where I was. We figured out the common ratio by what? Dividing. I know I was talking about these alternating signs. Any negative to an even power is positive. So that's why we got negative, positive, negative, positive. This is negative, even. That's going to be positive, odd. This would be a negative number, and this is even. So notice that that's how we alternate. Okay, so I've got my first 4 terms. I want to get the common ratio. I'm going to divide this divided by this, this divided by this, this divided by this. A sub n over a sub n minus 1. Okay? And you can do it in the calculator. You can just, if you know that you can simplify this where the numerators pair up. 15 over negative 15 is going to be negative 1, and 9 over 3 simplifies to be 3. Okay? So we can, and that's what I did here. The 15 over 15 is 1, the 9 over 3 is 3, the denominator simplified to this, and the numerator simplified to this. Okay? You can multiply by you can take the numerator fraction and multiply by the denominator fraction as a reciprocal and simplify. Here I did this, I just used negative 5. You should know how to do this. If not, use the calculator, but there's our common ratio, which we get from a term divided by the preceding term. And you do all of them, on your sequence here, you do all 3 of these maybe to show the common ratios. This divided by this equals this divided by this equals this divided by this, which is, they all equal this ratio, negative 1/3. So notice that's what we're multiplying everything by. The numerator gets multiplied by negative 1, which means negative 15 times negative 1 is positive 15 times negative 1 is negative 15, and so on. The denominator times 3 times 3 times 3. Okay? Common ratio, negative 1/3. If I have a recursive formula, I have this. Just all the recursive is how do I get the next term? I need to be given the first term, which we know is negative 5. Okay? And then the basic format is, hey, the nth term comes from the preceding term times r. With arithmetic, it was plus d. But for this, it's just the a sub n equals a sub n minus 1 times r. Okay? And all we need to do is fill in for r. This is the same for any recursive formula as far as arithmetic or geometric. In this case, instead of plus d, it's times r. So a sub n equals a sub n minus 1 times, what's the common ratio? Negative 1/3. There's my recursive formula, and we have to put the given, what the first term is. All right, now our formula for the nth term, very similar. It's just I get any nth term by taking a sub n equals your first term and times the common ratio and how many times we multiply by r, which is represented by an exponent, n minus 1. it's always one less than the term. If you want the 20th term, that means we multiplied the first term by r to the 19th power, times r times r times r, and so on. Okay? For this, here's our first term. I'll write it as negative 5 times negative 1/3 to the n minus 1 power. Sorry again, we got interrupted by an announcement. I had to click pause. Okay, so here is my nth term. The first term times the common ratio to the n minus 1 power. Here's my first term times the common ratio to the n minus 1 power. Okay? So if I want the 10th term, it's negative 5 times negative 1/3 to the 10 minus 1 power is 9. Okay? It gets me this number here. Okay? All right. Next, you're going to be asked to find a sum. Okay? And when we have a finite, which means not infinite, it doesn't go on forever, we're not summing up infinite terms, it's finite, which means there's a finish, there's only, in this case, 12. Okay? If it's a finite series, we're summing up the sequence of 12 terms, 1,000 terms, whatever, but a defined number, it doesn't matter what your common ratio is. It can be greater than 1 or less than 1. It's irrelevant because it's finite. Here's the formula for summing up a certain number of terms. Okay, your first term times, in parentheses, 1 minus the ratio to the n power divided by 1 minus r. Okay, so we would plug this in our calculator, and it would be s sub 12, the sum of the first 12 terms is going to be first term negative 5 times 1, notice in parentheses, 1 minus, what's that ratio? Negative 1/3 to the 12. It's important that if this ratio is negative, you group it in parentheses to this exponent. This will end up being a positive number, okay, because that's even. But anyway, 1 minus this right here, negative 1/3 to the 12th power, over 1 minus negative 1/3. Okay, and we'll plug this in the calculator and get our number. I actually put this in and I messed up. I kind of had a brain fart, and I did an n minus 1. I put in, you notice what my error is, I put in 11. Should have been 12. It's not n minus 1, okay? It's n. All right, so next. Now let's talk about infinite sums. Now, if we're summing up infinite amount of terms where there's no limit, we can only do it if the absolute value of our common ratio is less than 1. That means, you know, the absolute value of negative 1/3 is 1/3. That's less than 1. Okay. Anytime you've got a fraction, your numbers keep getting smaller and smaller, and pretty soon you're adding nothing, and the sum kind of hits a limit. You kind of ended up adding nothing. So here I've got my first term is negative 5 divided by 1 minus r. Very simple. 1 minus negative 1/3. So I've got negative 5 over 1 plus 1/3. 3 times 1 is 3 plus 1 is 4. So 1 1/3 is 4/3. Okay. So I've got negative 5 divided by 4/3. This 3 will come up top, and I've got negative 15 over 4. This is said to converge because why? My sum converges on a value because this common ratio, we're able, and the word converge and diverge, they're really applicable to infinite sums, okay? If my common ratio was, if we took like some first term and then we multiplied it by a common ratio of 5 to the n minus 1, this would be like a formula for the nth term. Okay, notice if we were summing up all these terms, if every time I multiply something by 5, every term is going to get bigger and bigger and bigger, and we will never converge on a sum. It's just going to get bigger and bigger. You're going to add 1 million, 2 million, 3 million. So that would be said to diverge. Okay, as opposed to converge. Okay. So that's pretty much it. We've kind of went through quick summation. We produced first 4 terms. We got a common ratio. We by dividing this a term by its preceding term. We wrote a recursive formula with the and all we needed for that was the common ratio. and given a first term, and then we can also use the first term of the common ratio to write a formula for the nth term, where we just write this right here, a times r to the n minus 1, a sub 1 times r to the n minus 1. We got our nth term. We got a sum for the first 12 terms using this formula, and then there's a different formula. If your common ratio is less than 1, you can sum up infinite terms. Okay, and that's a sub 1 over 1 minus r. And in this case, if the absolute value of your ratio is less than 1, it'll converge on a value, and you can use this formula. This formula is for finite sequences. Okay, and that's it. Enjoy. Hopefully this was short enough. Let's see what the time is. Okay, 10 minutes, 45 seconds.